All right, let's tackle Unit 3, Day 1, solving equations. At the very, very top, if you guys would write down your learning objective. We're going to solve two-step equations for x. First, I want to tackle some one-step equations. Okay, so if you guys would, in that top left-hand corner, copy down these two equations. All right, we want to solve both of these equations, but first, as I'm doing that, I want to give you a framework for you to solve all your equations with. And the first thing we're going to start with is a vertical line bar. It's going to go right down the center of the equation, right through the equal sign. That's going to separate your left side of the equation from the right side. Then, I want to think about undoing the operations that have been done to x. So you can see there that 8 has been added to x. So let's undo that plus 8 by subtracting away an 8. Then next, after you perform an action, I want you guys to draw a horizontal action bar there. And it allows us to reset what we've done. So for instance here, you can see that the 8's here are going to cancel out. So all we're going to have left on that left side is x. On the right side, we have 12 minus 8, or 4. And you can go ahead and check at the top that 4 plus 8 does in fact equal 12. Okay. Next, I want to take a look at the bottom here. I have x minus 8 equals 12. Okay. Well, I want to solve that x by undoing that minus 8. So undoing a minus 8 means to add away the 8. After we perform that action, we have our horizontal action bar. The 8's cancel out. All we have left is x. On the right side, we have 12 plus 8 equals 20. Okay, and you can see that 20 minus 8 does in fact equal 12. Take a moment to work these problems on the right. Make sure you include your vertical bar and also your horizontal action bars. Let's see what you get. Okay, for the first one, there's your vertical bar. We want to undo the minus 5. We'll do that through addition. And what we end up with here is x equal to 7. And 7 minus 5 does equal 2. On the bottom, vertical bar, we want to undo the plus 5 that's been done to x. So we undo that by subtracting it away. We just performed an action, so let's use our action bar. The 5's cancel out. We have x is equal to, on the right side there's a little tug of war, positive 2, negative 5. The negatives win by 3. And you can see that negative 3 plus 5 does equal 2. Okay, let's try a couple more one-steppers. So the next row of boxes, copy down these two equations. These will also only take one step to solve for, but here you can see that the 6 has not been added to x, but rather it's been multiplied by x. So in order to undo that multiplication, we'll need to use division. So here we're going to divide 6 away from both sides. The 6's cancel out. You end up getting 1x, or just x, which is what we want. So there's our action bar. We get 1x. 18 divided by 6 gives us 3. And you can check that. 6 times 3 does equal 18. On the bottom, let's do the same thing. Draw your vertical bar. You have negative 6 times x, so you want to go ahead and divide away whatever's in front of x, what we call the coefficient. So if the coefficient's negative, we divide by a negative. There's your horizontal bar. Negative 6 divided by negative 6 is a positive 1, so we get 1x. On the right side, you get a positive divided by a negative, you get negative 3. Okay. Take a moment to try this with the ones on the right. Okay, vertical line bar. We want to divide away that negative 3. We just performed an action. So we end up with x is equal to negative 4. On the bottom, we want to divide away that 3. We get x is equal to 4. Okay. That's how we solve one-step equations. If it's addition, you subtract. If it's subtract, you add. If you have multiplication, you'll divide. If you have divide, you'll multiply. You'll undo the operations that have been done to x. Well, the question then becomes, what happens if both operations have been done to x? Okay, so let's go down to the bottom half. And up here in the top, the middle bottom right corner, right below your two-step equations, let's copy down a couple of things. First, I'd like to copy down the order of operations. So take a moment to copy this down with me. Remember that as you go through your PEMDAS, you have parentheses, exponents, multiplication and division, and then addition and subtraction. Okay? Well, you'll remember in the first two units that when you're simplifying expressions, write this down with me, over off to the side here. When you're simplifying expressions, you follow the order of operations. In other words, you just go through that order, 1, 2, 3, 4. However, you're going to see in this unit, when we begin to solve equations, so solving equations, that we're actually going to go through the order of operations backwards. In other words, we're going to perform addition and subtraction first, then multiplication and division second. Let me give you an example. Let's say I have 3x plus 4 equals 22. Copy this down with me, please. If I want to solve for that x, I've got two things I got to get rid of. I've got the 3 that's being multiplied by x, and I also got the 4 that's being added to x as well. So the question becomes, what do I get rid of first? Well, we're going to go through the order of operations backwards. So what we're going to take care of first is getting rid of that 4. Okay, so to get rid of the 4, we're going to need to subtract it away. So let's subtract away 4 from both sides. We just performed an action on both sides. The 4's cancel out. What we end up with is 3x is equal to 18. Now we still need to get rid of that 3. We'll do that through division. We just performed an action, so here's our action bar. 3 divided by 3 is just 1. We get x is equal to 6. If you go back up to the top, 3 times 6 is 18. Add 4, you do get 22. Take a moment here on the right side to solve this two-step equation. Make sure you use your vertical bar and also your horizontal action bars. Go for it. Okay. To solve for this, we're first going to have to get rid of that subtraction of 8. So we'll do the opposite, and we'll add 8 to both sides. What we end up with after we reset here is 5x is equal to 20. We still got to get rid of the 5, so we'll do so through division. We end up with x is equal to 4. Now, many students are going to ask me, Mr. Goethals, do we absolutely have to do those vertical bars, those horizontal lines? The answer is yes. In order to get full credit, you will have to show all your work, and this is how I want you to show your work. Okay, let's go down to the last row of boxes. Let's copy down this problem. Okay, let's solve for x by undoing the order of operations. So vertical line, let's do addition and subtraction first. So let's subtract away that 3. Reset. What's left over there is the negative 4x. And on the right side, we get 28. We still got to get rid of that negative 4, that coefficient in front of the x. Let's divide that away. Action. We get negative 4 divided by negative 4 is a positive 1x. 28 divided by negative 4 is a negative 7. Okay. If we try to plug that back in for x, negative 4 times negative 7 gives you a positive 28. Tack on 3 and you get your 31. So that works out. Try this last one on your own. Remember, use your vertical lines and also use your horizontal action bars. Go for it. Okay, let's add away that 11 first. Okay, then we'll divide away the negative 7. What we got left here is x is equal to negative 11. All right, look forward to seeing you in class.